Hello everyone, my name is Jinhao. I just get my bachelor's degree and start my PhD life in Peking University. It's my honor to introduce our recent work on regression testing acceleration. In the evolution of a program, developers often modify the old program P0 and get a new program P1. The modification may contain bugs, so developers need to rerun tests on modified software to guarantee the quality. This is called regression testing. However, regression testing is time-consuming. It accounts for more than 80% testing efforts, and the frequency of modification and regression testing is very high. Rerun all the tests each time modification happens is infeasible. To reduce the cost issue of regression testing, researchers have put dedicated efforts in test selection, reduction, and prioritization. Test reduction aims to reduce a test suite by removing redundant tests. Test selection aims to select and run the tests relevant to software modification. And test prioritization aims to schedule the execution order of a test suite. The commonality of them is that they all optimize the execution of the whole test. However, each test will be executed completely. In fact, modifications between two versions is minor. P0 and P1 is similar. For one individual test, we can notice that during execution, some of the program states of P0 may be the same as P1. The state here is referred to a set of variables values during execution. So I have a question. Since the states are mostly same, is it necessary to execute the test completely once again? The answer is definitely not. For the program states unaffected by regression modifications, we can directly reuse them and skip the relevant instructions. Based on this intuition, we reduce the regression testing cost from a totally new direction, optimizing the execution process of an individual test. In this paper, we propose a state reuse-based acceleration approach, SRRTA. SRRTA consists of two components, state storage and state loading. In state storage, SRRTA sets storage points at predefined code locations and collects program states during the execution of P0. In state loading, SRRTA skips the instructions unaffected by regression modifications and reuses these program states during the execution of P1. Next, I will use an example to introduce the state storage and loading. State storage is to store the program states at storage points. First, we will select several code locations as storage points. For the example is storage point 1, 2, and 3. And then during the execution of P0, store the program states at these locations. As we can see, as the second column, SRRTA collects 3 sets of program states. State storage induces extra overheads in the execution of P0. Therefore, when we select storage points, they should be set as few as possible and help skipping more instructions. Based on this requirement, we select the storage points to guard potential time-consuming code locations. We propose 3 storage strategies. Set storage points at entries and exits of loops, conditional statements, and method invocations, respectively. Let's return to the example. There is a modification, replace plus with minus. Next is the state loading process. State loading is to reuse the stored states and skip the instructions unaffected. Whether state loading can be conducted depending on whether the transition between two adjacent storage points is safe. The requirement of safe transition is that between two adjacent storage points, there is no modified instructions and no instructions accessing the variables whose values are changed on the first storage point. In the example, the transition from storage point 1 to point 2 is unsafe, since there is a modified instruction between them. Thus, SRRTA executes all instructions between storage point 1 and 2. The transition between storage 2 to 3 is safe. Although program states are different on point 2, the polluted variable C is not accessed by any instructions between point 2 and 3. In fact, between point 2 and 3, only matrix is accessed. Therefore, SRRTA skips the execution of the entire loop by directly loading the program states on point 3. We implement SRRTA with the bytecode manipulation framework, ASM. We insert all the possible transitions on each storage point with conditional judgments to determine whether to conduct transitions or not on the fly. We conduct a preliminary study. We study two research questions. In RQ1, we study the performance of SRRTA on reducing regression testing time. In RQ2, we study the influence of different storage strategies on SRRTA. This is our result. For RQ1, shown by the second row, SRRTA with the default setting successfully accelerates all the 15 regression testing cases with 82.7. For RQ2, we can notice that the storage strategy indeed affects the performance of SRRTA, and a store loop, this strategy performs the best. Finally, to summarize our work, we open a new dimension for regression testing acceleration, that is optimizing the execution process of an individual test. We propose a novel acceleration technique based on state reuse, and our proposed technique SRRTA can reduce regression testing time a lot. Here comes to the end of my presentation. Thank you for your listening.
Okay, thank you for your presentation. Let's see, questions. I've been copying these papers. Okay, so I guess it's definitely a good idea. Some similar things were explored in the past. I don't know if you're familiar with this work, something called test carving. Hello, Jinhao, do you hear me?
Yes. Can you repeat the question?
We do not hear you well. I think you changed something with your microphone. My question is, how does your work compare with the test carving? Did you look into work on test carving?
Oh, sorry, I don't understand that.
You don't understand. Okay, that's fine. I'll just try to write here. Let's see. How about if I write in Zoom chat? Can you see that? I'm yelling. I'm not sure if that helps. Your microphone also something changed. I barely hear you. Did you look into related work or prior related work? It's fine if you're not familiar with this work. Maybe you just mention it in the paper. But here's some of these papers. Do you see my question now on the Zoom chat?
Okay.
We got a few more questions, so I'll be asking the other ones. Are you familiar with any of these papers, or?
You see, these papers you list have the similar points with ours.
Yeah, I mean they store and restore states in various kind of forms and shapes. Also do something else, turn system tests into unit tests and do various other things. I mean, it's fine. If you're not familiar, you can just go and read them and see what they're about. Let me go to the other questions. One is whether your implementation is available online.
Yes. As the SRRTA collects the states as a runtime.
Okay. There is also a link maybe in the paper. Another question is, what's the end-to-end time of your technique, including the overhead? Not just the time to run the test, but kind of overall to even store the states, restore states, everything, end-to-end.
Yes. The overhead is not trivial. So this is one part we need to solve in the future. But the overhead SRRTA brings is less than the increment brought by SRRTA.
Okay. So let's see. The last question I have here is how large is the state storage for an example unit test? So when you store the whole state, and I don't know exactly what you capture, heap, threads, what exactly you store, how big is that state?
You mean the space?
Yes, the space, the kind of the space overhead or the storage requirement. How much memory or disk space do you need to store this state?
We listed the space in this paper.
Okay, so basically the answer is
as you can see in this column. We conduct the experiment at the Apache Commons project, and the space SRRTA brought is listed as this column.
Okay, I assume this like in something bytes, kilobytes, megabytes.
Kilobytes.
Okay. Okay, so if you store all, so that's about like 97,000 kilobytes, about 100 megabytes, right? The first one. That's fine. Okay, any more questions? Let me double check here in this Q&A. I believe I asked everything. I apologize if I missed something. Here we don't lose the questions after the talks. I need to scroll to the whole thing. Thank you, everyone. Thanks all three presenters for the presentation. It's important to improve efficiency of our testing so we burn less electricity and find more bugs. That completes this session. Please enjoy the other ones. Thank you. Bye.